Hey, what's up YouTube? It's Christine with Gauge Girl Training, an online meal planning and coaching service. I'm a food scientist and chemical engineer by training, and today we're going to talk about how fat loss works. So let's get started. So a lot of you guys come to this channel looking for educational content on how to maximize your fat loss, your weight loss, and a lot of people have questions about fat loss, and there are very big misconceptions about fat loss. Misconception so big that I just couldn't be quiet anymore. I really needed to speak up and explain to you guys some of the technical content and biochemistry that happens behind the scenes of how fat loss really works. It's so crucial to grasp the fact that food is so much more complex than just energy in the form of calories, because just because you are burning calories does not mean you are burning body fat. Legit, true fat loss occurs when free fatty acids are used for fuel in the body as opposed to glucose. Glucose is your human blood sugar. So if there is ever a need for more energy than the carbohydrates floating around in the form of glycogen, the cells will switch to those fatty acids for fuel with a process known as lipolysis. I'm going to draw this on the board and explain to you what lipolysis is and take you through the biochemistry of how it works and show you guys the net overall chemical reactions of what real fat loss actually means and how you can apply this to your life. Alright, so I'm first going to walk you through the process called lipolysis. Lipolysis is when you have a triglyceride, which is fat, and it's broken down into two components: glycerol and free fatty acids. I'm going to draw out these chemical structures and explain what they mean. A fatty molecule, also known as a triglyceride, is made up of a glycerol backbone and a free fatty acid. Here's what that looks like. So what's that mean? Here's glycerol right here, 3 carbons, 3 OHs, like this. So you have a carbon backbone bonded by hydrogens, and you have the hydroxyl groups here. A free fatty acid, we have a carboxylic acid group right here, and each one of these lines right here, if you can see, so literally if I drew this out in detail, take the O double, this is actually a C, a carbon, O minus. Every one of these marks right here, just some basic chemistry, that's actually a carbon. So each one of these is a carbon, and you're always assuming each carbon is bonded by the hydrogen group. So I could go on and on and on, but the reality is this is just a shorthand version of how you write out a free fatty acid. So what ends up happening in a fat molecule, and why fat molecules are so big, and why fat as a macronutrient is 9 calories per gram to break it up, is because it's a big ass molecule. It's big. So you have the glycerol, you have the free fatty acid. So this is what a triglyceride looks like right here. So this is a triglyceride. So again, the glycerol backbone right here, the 3 carbons, and each one of these carbons is connected to an oxygen, which is the full chain of that fatty acid. So when you are burning fat, actually burning fat, what's happening is you are cleaving these bonds right here. This whole fatty acid is released, and then you're left with glycerol over here. Same here. All of this stuff needs to be broken apart in order for that to happen. And that, my friends, happens through a process called oxidation. So let's talk about oxidation. When a triglyceride is oxidized or burned up, this process consumes many molecules of oxygen while producing carbon dioxide, CO2, and water as a byproduct. Body fat will be used for fuel when your glycogen is depleted and a certain level of oxygen is present to support this type of oxidation. From a survival standpoint, the body does not want to part with stored body fat. Let me repeat that. The body is not trying to get rid of stored body fat. Like, while you may want to look a certain way, that's not how the body was programmed. The body is intelligently designed. The body was designed to anticipate periods of scarcity when you would not be fed. So if you're under eating, your body does not want to part with your stored body fat, because it's like, you know what, I don't know when she's going to feed me again. I want to make sure I don't die. That's as crazy as that sounds. So you might be one of those people that's just under eating and you're not losing weight and you don't know why, and you're not losing fat. It's because of this scarcity complex where your body wants to hold on to your body fat, and it won't release the free fatty acids because it wants to use up all the glycogen first, and your body is preferentially storing that fat and doing everything it can to not let that go. So all fats, whether they are a liquid form or a solid form, exist in the body in the form of triglycerides, which again consists of a glycerol backbone and free fatty acids. All right, so when we're talking about the metabolism of fatty acids, all fat, whether they're solid or liquid, they exist in the chemical form as triglycerides, again, which I showed you guys on the board, which consists of glycerol backbone and 3 fatty acid chains. Now, these triglycerides, again, they're stored as oil droplets within fat cells that make up adipose fat tissue located throughout the body, where obese individuals possess fat cells overflowing with excess triglycerides. Now, when one is inducing a caloric deficit through reduced caloric intake or increased physical activity with the goal of fat loss, here's what actually occurs. So if you look at this chart here, the triglycerides, they're going to receive a signal from the hormone-sensitive enzyme known as lipase. This results in the triglycerides breaking down into their components of glycerol and fatty acids, which are then absorbed into the bloodstream. So what you can see right here, we're talking about the metabolism of fatty acids, because burning those fatty acids off is what's going to change the way your physical body looks. From here, the liver is going to absorb the glycerol and a portion of the fatty acids, where the remainder will be absorbed by the muscle cells. So you can see here the fatty acids, some of them are going to go to the liver. Once inside the liver or muscle cells, the triglycerides are then disassembled, and it results in large quantities of a compound called acetyl-CoA. So you have the fatty acids going here to acetyl-CoA. Now, this compound, acetyl-CoA, what ends up happening is acetyl-CoA combines with a compound to form citric acid within the cells, mitochondria. Now, this reaction kicks off the citric acid cycle, also known as the Krebs cycle. This reaction kicks off the citric acid cycle, also known as Krebs cycle, a set of chemical reactions that creates usable energy from fat, proteins, and carbohydrates. As these mitochondrial activities unfold, what ends up happening is they generate carbon dioxide, water, and heat, as well as ATP, the energy-carrying molecule that fuels extracellular activities, where the carbon dioxide is expelled from the lungs during exhalation. Water exits the body as urine and perspiration, and heat that is generated helps maintain the body temperature at a comfortable 98.6 degrees Fahrenheit. So what has to happen in order for your body to metabolize fatty acids, again, is those triglycerides need to be broken down into the fatty acid chain and glycerol. In order for that to happen, your body needs to have an excess of oxygen. I think that's the takeaway message here. Your body needs to have an excess of oxygen, and you need to be depleted in glycogen in order for this to occur. Just because you are burning calories does not mean you are burning fat. So the solution is, if you want to make sure that you're burning the proper amount of fat, is you need to adjust your nutrition. It's not about working out and working out and working out and working out. If your macros are not dialed in, you are not going to truly lose body fat. You could lose weight without losing body fat. So if you're confused on what your macros should be, I suggest getting a custom meal plan from GageGirlTraining.com. If there's any other questions or concerns, please comment below. But thanks for watching and have a great day.